Hello everyone, I hope you're having a nice time so far. I'm very excited to introduce our next speaker, Anastasia, especially because we met recently in a conference. She's a talented software developer working in a consultancy company that creates software for Swedish energy companies. Today, Anastasia will be sharing insights about Python profiling tools. I'm sure you will find very interesting the guidance on when and how to use them to make your code run faster and more efficiently. Please join me in welcoming Anastasia.
Hello to all participants of PyLadiesCon. It's nice to be here. This is my first time at PyLadiesCon. I've never participated before, and I hope you're gonna like this presentation. I hope it will be interesting and most importantly, useful for you. And before I start, I just wanted to mention that you might hear some weird sounds on the background. And if you do hear some sounds that remind you about Chewbacca from Star Wars, it's most probably my cat because she got kittens and she's extremely vocal with them. We are a bit tired of that, to be honest, but what we can do. And yeah, if you hear some weird noise, it's most probably her. And it would be crucial to mention kittens and not to show you any picture of those. And I'm not a criminal. So here you go. Those are the pictures of our kittens. They are, of course, adorable. This is the smallest one of those. Yeah, there is one little boy that looks like a demon, and that's the mom. And I think it's a great starter of our presentation, and we can continue. And I'm going to mention a little bit about who I am. So my name is Anastasia. I'm living in Stockholm, Sweden. I recently became a co-organizer of PyLadies Stockholm chapter. So if you are ever in Stockholm, you are very welcome to chat with us, to come to our meetups. Please feel free to send me a message on LinkedIn. I would be happy to know that you actually saw this presentation and you found something interesting, you learned something new. So please feel free to do that. And I'm working as a backend developer at a company called Helicon Technologies, where we create software for Swedish energy companies. It's a consultancy company. And I actually don't have any technical background. I don't have like computer science degree. I've never been to any boot camp. I'm all self-taught. Very proud of that. Not an easy way. It was very hard, but I'm happy to be where I am now. And I used to be a dance teacher before in my home country, and I still enjoy dancing. It's a big part of my life. And apart from that, I enjoy hiking, skiing, and roller skating. So let's continue on the main topic. So what is code profiling? If you never heard about it, it's absolutely fine. I'll try my best to explain what is it and why do we need to know about it. So in a way, code profiling, it's kind of like putting a magnifying glass on your code and trying to understand how it uses the time and resources. And profiling going to help you to identify what parts of the code are the slowest, how much memory does it take, where the most of the memory are used, and what function were called the most. And we care about it because it's going to help us to improve the performance of our program, of our code, making it faster by focusing on the slowest parts. It's going to help to optimize the resources, so reduce the memory or CPU usage. And most importantly, it's going to help to find us those bottlenecks that we have in the code, those smallest maybe areas that is slowing down the whole code, because it's usually not the whole code base. Those are just little places that's slowing you down, and it might be very hard to find them. And this is where profiling helps. So in a way, it's like debugging, but instead of finding bugs, you're finding the slowest places of your code that's slowing everything down, and you're trying to find ways to make it more efficient. And I have a real example from my work where profiling helped. So we had a code that in the future supposed to have a lot of users, and we wanted to see how it performed. And we noticed that when we generated a big chunk of test data with 20,000 users, it was super slow. So that was the moment for me when I got introduced into code profiling. I wanted to see what was the problem, what was actually taking so long. And I used profiling on that. And as you can see here, the main script took a lot. It took 16 seconds to run with those 20,000 users. And our first thought was to suspect that this is the fault of the query that is running with a Django object relational mapper that we use to talk with our database, because we were using framework called Django Ninja that is using Django object relational mapper for the database. And we was thinking that this is the main point. This is the main issue. But when we started to look deeper into it, and I used those profiling tools, we realized that the query itself actually is taking just 0.2 seconds. So it's pretty fast. But formulating the query took a long time. And it happens because we have a model called resources. And it's actually a big resource tree. So it can have children that can have children, and etc. And when the query is formulated, it has first to retrieve all UIDs of each parent, and then of its children, and then of children's children. So the query itself running fast, but it's huge, and to formulate it take most of the time. And when we identified the problem, we could easily fix it with just actually a few lines of code. And we increased the performance significantly from 16 to just 1.7 seconds. So that's just the example I can show you from my work. So pretty neat, pretty neat. And let's continue, and let's first speak about why do we actually care about it in Python. We especially care about it in Python because it is an interpreted language, and it helps us to write the code faster, because it's like writing in English, super easy and very understandable. But unfortunately, when we are talking about the CPU usage, execution speed, and its performance, it's far from the top, as we can see here on the schema. And if you get this presentation in the end, which I hope you will, you can click on the link here and read an article about the efficiency, energy efficiency of programming languages to learn more about it. But let's continue. So to improve that, we can use profiling. And actually, whenever you have a task to improve the performance of the existing application, try to use profiling. And in this presentation, I'm going to talk about 5 profiling tools. 2 of those are already a part of Python standard library, meaning you don't have to even install anything. It's already there for you, waiting for the usage. And 3 others is Line Profiler, PySpy, and SnakeViz. Has to be pre-installed. Let's go to the time model, to the easiest one. So I have a very easy code example for you here with just 2 functions, both summarizing the range of numbers. And slow function is not actually super slow. And the range is this one. And memory hungry function is much heavier. It's using least comprehension, and the range is bigger here. So that's why it's memory hungry. And what I'm doing here with time module, importing it first, of course, and then when I'm starting the main script, I'm starting the timer also. And I'm saving it here in the start time. And then when I finish the first function, I'm trying to see the difference between the start time and the current time, and doing the same for the second function, and printing out the difference. So I did that from my script and got some result, and we can see that slow function takes 0.05 seconds, and the memory hungry one takes 6 seconds. But that's all in time module. You don't get any extra stats. So to get some extra stats, we move on to the next profiling tool called cProfile. And it's already there, ready for you to use it just with this command, Python M for module cProfile and the name of your file. And those are the stats that I got, so much bigger. We have a lot of different information here. And we can see that the cumulative time was 6.3 seconds for it. So that's something that we expect. And let's take a look at what are actually those columns. What do they mean? So here we have number of calls, meaning the number of time this function was called. We have total time spent in the function itself, not including time spent in other function it calls. We have time per call, which is basically total time divided by number of calls. We have cumulative time, meaning total time spent in the function, but this time including time it spent in other function it calls. And we can also see the line number that helps us to identify where the function is defined in the code. So those are the stats. And we're going to see a little bit more how cProfile communicate with some other tool I'm going to show you in the end. But otherwise, let's move on to the next one called Line Profiler. And Line Profiler does what you think it's going to do. It's going to break your code line by line. And you have to pip install it before. And then you need to use the profile decorator for the function that you want to profile. And then you need to use the command for executing the script, this kernproof -l for line by line profiling, and the -v for displaying the result in the terminal and the name of your script. So I did that for the code I showed you before, and those are the stats that I got. Interesting thing that it shows, here we can see the percentage of time that it spent on running each line. And here we see that most of the time, 51, almost 52% for the slow function was at this line. And for the memory hungry function, most of the time it's spent in this list comprehension line, which is what we expect. We can also see that total time is of course larger for the memory hungry function, almost 6 seconds. And most cool feature of Line Profiler that we can actually see how our code ran line by line and follow it. So that's it about Line Profiler. Let's talk a little bit about PySpy. And PySpy was a little bit tricky for me. And it's gonna be also tricky for you if you are on Mac, especially on the latest version of Mac. And if you are using Python newer than 3.9, because of the thing on Mac called SIP, System Integrity Protection. And if you get the presentation, you can follow the issue, the open issue here, and see what is actually happening behind the scenes. But what helped me is just to downgrading to the lower version of Python. I use 3.9 to make this code work. What's cool about PySpy is that you don't have to do any modifications to your code. And you don't have to even restart your program. You just need to retrieve the ID of the running process. You have to pip install it though. And then you can use 2 types of commands depending on if your code is running or not. So if it's running, you are going to use this one and you're going to run your script. And if not, you have to identify the PID of the process and attach it to PySpy. And then no matter of what command you used, you can visualize the data with PySpy. So I did just that, and let's see the stats. Here we see an interesting line saying total samples. So here we have total sample 300, which means that PySpy took 300 snapshots of the call stack during the execution of this script. So it's quite precise. Global interpreter lock was held 100% of the time. And if you don't know what is global interpreter lock, you can read a little bit about it. Unfortunately, we don't have time at all to talk about it, but it's a cool thing to know about in Python. So I totally recommend you to read a little bit about it. And we have a thing called active, meaning that this process was actively doing work 100% of the time. It wasn't waiting for anything, wasn't waiting for any input-output operations to happen. And it was a single-threaded process. Interesting thing you can see here is list comprehension is a separate process in PySpy. So what happens is PySpy splits list comprehension into its own function like entity. So they are kind of executed internally in a separate scope. This way you can see its own time here for the list comprehension in this file. What I was surprised to see in PySpy is that it took much faster. Before it was 6 seconds, around 6 seconds for the whole script to run. Now it's just 2.9. I was so surprised to see that. For me, it seemed that the 3.11 version supposed to be faster, but I downgraded to 3.9 and I saw that. I was very surprised. If you know why is it happening, please feel free to ping me on LinkedIn. But yeah, let's move on to the last and my favorite tool called Snakeviz. So what Snakeviz does, it's using stats output that you get with cProfile, and it's visualizing it, making it colorful and interactive. So you have to pip install it, as I said before, and then you can use this command to create an output with cProfile, and then you can visualize it using Snakeviz. So I did just that for the script that I showed you before. And this thing, the way it's visualized right now called Icicle, I prefer that, to be honest. You can also use Sunburst. It's kind of like a pie chart, but I don't really understand that one. This is much understandable for me. And you can play with style, depth, and cutoff. We don't have time for that. But what I wanted to show you here is that it's interactive, meaning you can zoom into each function. And let's zoom in the main code. And if we do that, we can zoom into the profile, into memory hungry function. And in here, we can see that list comprehension was taking most of the time. So pretty neat. And you can also follow the stack so you can see how you even got into there, so you are not lost. And you can always go back to the very beginning by clicking this reset zoom button. So I think it's very useful and quite understandable if you want to share your stats and explain it to someone, because with just numbers, it might not be as cool to see, as understandable and as interactive. And those are the stats that we already saw before in cProfile, but just in a little bit better visualized way. So summing it up, profiling is a very great tool to write, to make your code faster and smarter. And why it matters is because profiling is a very good tool for identifying those bottlenecks that you have and making good, proper decisions about your code, understanding your code better. And it's going to help us with time and efficiency because sometimes even a very small optimization, just one line of code, can significantly improve your code. And we should remember that optimizing code is not just about speed, but it's about writing efficient, maintainable, and scalable applications that perform good under different real-world conditions. So that's all for me on profiling tools in Python. I hope you enjoyed it. I hope you learned something new, and please feel free to send me a message on LinkedIn and ask any questions. Thank you so much. Enjoy your day. Enjoy other presentations. It was very good to have you here. Thank you. Bye-bye.
Thank you to our speaker for the useful presentation and of course for sharing the cat pictures with all of us. They are so cute. Thank you very much again. And of course, to our audience, remember to ask your questions to our speaker in Discord. See you there.